Hello everyone, myself Yadagiri, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. The last session we have discussed about the module number 1, that is the DC circuits, that are we can say the unit number 1, that is the DC circuits. In this module we need to discuss about the AC circuit, that is the second module of the subject, that is a BEE. So that is AC circuits, or we can also say the unit number 2 in the BEE, that is the AC circuits. So before going to involving into the whole AC circuits, first we would like to discuss about the fundamentals in different fundamentals or different concepts in AC circuits. So before going to dealing about the fundamentals of the AC circuits, we need to discuss about the what does it mean by AC circuit. So the AC circuit is nothing but it is a closed path chosen by. So it is a closed path chosen by an alternating current, that's called simply AC circuit. So that is the closed path chosen by an alternating current is simply called AC circuit. So previously we have we have discussed about the DC circuit. This circuit nothing but it is interconnection of the various electrical components like electrical elements, resistor, inductor, capacitor to form or to maintain at least one closed path, that is DC circuits. In case of this one, the AC circuit is nothing but so it is a closed path followed by an alternating quantity or AC current is called simply AC circuit. So this is a AC source which delivers some current towards any element. We choose the closed path. So simply it's called AC circuit only. So AC we are going to represent in terms of either sinusoidal or so other AC signals like triangle, and also we can say so rectangle. So these are all we can consider as a AC circuit. AC signals only. So based on this one, so whatever the alternating quantity followed by the closed paths, that is simply called AC circuit. So this is regarding AC circuit, and also we have and one more the thing, that is the alternating quantity. So AC circuit is that one. Then we will discuss about the right now alternating quantity. So alternating quantity means so it is a voltage or current. So the one which change its polarity and magnitude. Let us say it's a current. So it is a kind of alternate quantity which is used to change its polarity and magnitude with the regular interval of time. So that is this is 0 and this is the pi, and it's a 2 pi, then 3 pi, then 4 pi, etc. So it is an alternating quantity, so which changes its magnitude and as well as their polarity with the regular interval of time. So it's called simply alternating quantity. Simply say the alternating quantity nothing but it is a voltage or current, one which change its polarity and magnitude at a regular interval of time. That's simply called as AC, alternating quantity. So in this we have considered as either the voltage or current. Voltage or current means we need to discuss about the AC current. So AC current nothing but so it is a current which changes the polarity and magnitude at a regular interval of time. It's simply called AC current. And coming to the AC voltage nothing but it's also in alternating quantity. So AC voltage, so it is also an alternating quantity, so which change its polarity and magnitude at a regular interval of time. So let us say it's a voltage, so it is used to change their magnitude and as well as their angle, we can say polarity. So based on that one it will change their two parameters, that is again a alternate quantity, that's none other than voltage only. So AC voltage nothing but it's a voltage which changes its magnitude and the polarity at a regular interval of time. It's simply called AC voltage. So these are the very basic fundamentals in AC circuits. AC circuit means so a closed path followed by an alternating quantity or alternating current is simply called AC circuit. So we need to say the alternate quantity in the AC circuit. That's why the alternate quantity nothing but it is a voltage or current, so one which change its polarity and magnitude at a regular interval of time. It's simply called alternate quantity. So voltage and both currents are comes under the category of alternate quantities only. So this is the very basic fundamentals in AC circuits. So now we will discuss about the more fundamentals, in detail fundamentals of AC circuits. So that is a very one. So before going to involving into that kind of things, then we will discuss about the different signals. So this is the signal number 1 and this is the signal number 2. This is a one signal, other signal, and also other one more signal. So and also I would like to draw one more signal like So this is the one kind of signal. So this is the, let us say, signal X and with respect to time, and this is also one kind of signal. So this is again we can call it as a Y. Then this one is at with respect to t. Then so these are different signals are there here. So need to identify what kind of signal is belonging to the it is AC and what kind of signal belonging to the DC. So that we need to identify it. So based on the their magnitude values, we can simply identify. So this one is a, so this one is called direct to current signal. I mean DC signal. So it's simply we can call it as a fixed to DC signal. It is a fixed to DC signal. So this one is fixed to DC signal. So also we can say it's a unidirectional signal. This one is a unidirectional signal. So the signal which follows the only one direction to give the fixed magnitude. That's why it's called unidirectional signal. So it's also a unidirectional signal. I mean DC signal. DC signal. So in detail point of view, we can call it, it's a pulsating DC. So pulsating DC signal it is. So this is the D signal, or we can say unidirectional signal. It is a unidirectional signal it is. So it's also a kind of unidirectional signal. So because it's in terms of negative, because so it is also following the one direction only. That's why it's called unidirectional signal. But in terms of negative, it is unidirectional signal. So these are three. Here we have simply we have drawn the 5 signals. So from the 5 only we are going to consider the 3 signals under the category of DC, and the remaining and also this one also DC signal only. So this one also DC signal, DC, or we can say, so I mean a variable DC, or also we can say this one is pulsating DC. So pulsating DC signal. So from this 5 only the one signal is under the category of alternating, other one is a other 4 signals are under the part of D signal. So this is called simply alternating signal, AC signal. AC signal it is a AC signal, or we can say sinusoidal. The name of this one is sinusoidal signal. So sinusoidal signal. So these are the different signals like AC signals and DC signals. So in this we need to discuss about the different kinds of fundamentals in the AC signals or any DC signals. In a circuit we need to deal about the different fundamentals. So let us take this signal. So the signal value is this one at this corresponding instant. So it's also one of the value of the signal at this instant. So based on this one we can say, so it is the values of, these are the values of the signal. So at a particular instant, it's a values of the signal at a different instant. So this is the value of the signal and the corresponding instant. This is the value of the signal at this instant, and this is the value of the signal at this instant. So these are values of the signal at a different instance. So simply it is called instantaneous values. Simply it is called instantaneous values. So these are the instantaneous values of the different signal. Let us say this is the one value at this instant. This is the one other value at this instant. So this is the other value at this instant. So this kind of all instants of the signal is called instantaneous values. So the instantaneous values are nothing but it is a value of the signal at a different instant of any quantity, either alternating or non-alternating. That's simply called instantaneous values. So we are going to represent the instantaneous values of any signal with the small letters. If it is a voltage, we can take it as a V. If it is a current, we can consider as a I. Means every instantaneous values of the signal we can represent with the small letters. So now coming to the other aspect, other thing, that is, let us say this is the one point, one instant of the signal. So then the corresponding value, this one, this is the value of the signal and the corresponding instant, this one. So this one we can say, so it is the the value of the signal at a particular instant. Let us say, suppose this is a value at this instant. So it is a value of the signal at a particular instant. So this one is simply called magnitude. So it is the other fundamental thing of the AC circuit, that is called magnitude value. So the magnitude value is nothing but it is a value of the any quantity at a particular instant. That's simply called magnitude. So this is the instantaneous and also the magnitude. So for suppose the same signal has this is the value, and at this instant. So this corresponding instant of the value is called simply amplitude value. It is amplitude. It is amplitude. I mean, what does it mean by amplitude? Means, so it is the maximum magnitude of any quantity. It is a maximum magnitude of any quantity is simply called amplitude. So this amplitude we can also call it as a peak value or maximum value. So maximum value, or also we can consider as a crest value. So these are all saying about the maximum magnitude. So the maximum magnitude of any signal is simply say, so it is the maximum magnitude of any quantity, either the alternating or non-alternating. It's simply called amplitude value or simply peak value. So these are the different the signals. So like the AC and DC. So it's all, yeah, the whole analysis is applicable for each and every signal. Like all kinds of variable DC signals are. We need to discuss about the instant. I mean, we need to. Yeah, telling about these instantaneous values and also the magnitude values and also the peak value and also the amplitude value. So these many things we have considered under this variable D signals. So we can't say about the instantaneous and the remaining values towards this what fixed D signal. Only we need to taken these all values from this the variable D signals and also the alternating signals. So and for suppose let us take this alternating current. I mean this AC signal or sinusoidal signal. So from this point, from this point to here, from this point to here. So this is the, so with respect to time, we need to consider the magnitude of the signal. So this change the polarity and magnitude at a regular interval of time. So that's the alternate quantity. We can already so discuss what that is. I mean, we have already discussed about that. So this is the minimum span of the signal. So this is the minimum value of the signal. So what I want to say means it is a minimum value of the signal. So which breaks are separate to the repeated waveform. So hence this phenomena is simply called time period. So this is the time period of the signal. So let us take this one. Same only I am going to consider here. So this is the alternating quantity or AC signal it is. In this AC signal, so this the signal starts from 0 and end by here. I mean this instant we consider 0 and this one is a pi and this one is a 2 pi and this one is a 3 pi, this one is a 4 pi, etc. So this is the minimum value of the signal. In the whole entire signal, it is a minimum value. So we can simply define it is a minimum value of the signal which separate the repeated waveform. That's simply called time period. Other words also we can define the time period of any alternative signal, that is, so time taken to finish one complete cycle. So that's simply called as one time period. So the time period of any signal, so we can represent the capital T. So capital T equal to, we need to write so 1 second upon cycle. So 1 second upon cycle. So it is measured always in terms of the time period, means seconds only. I mean how much time in second to finish one cycle. That's called simply time period. So this is the time period of the alternating signal. And the other thing, the cycles per second also we can say, sorry, the second per cycle also we can say, or a time taken to finish one complete cycle also we can say the time period, or it is a minimum value of the time which separate the repeated waveform. Also we can simply say time period of the signal. So this it is always represented by the capital T. So that is measured in terms of the seconds only. So this is regarding time period, and also we need to go with the one more fundamental. So in the AC circuits, so that is a cycle. We can take cycle. So it is a minimum value of the signal. So for suppose let us take a alternative signal, that is a sinusoidal signal. So this is the sinusoidal signal. It's a 0, it's a pi, it's a 2 pi. So it is a minimum value of the signal. This is the minimum value of the signal. Again, which present or which appear in the span of this period. So that's simply called cycle. So that is we can simply consider this one. So it is a minimum value of the signal. So which present in the period of the one time period. So that's simply called as cycle. This is one cycle. Also, in other words, we can define the cycle. The cycle nothing but here. So cycle means it is a minimum value of the signal. So which is presenting in the period of the one time period. That is called simply cycle. Other words also we can define, that is a it is a set of two alternations. Set of two alternations. So is called as simply one cycle. One alternation, nothing but this is the one alternation with respect to time. So this is the t. It is any signal we can consider the x or y something. So it is a one alternation. The span of one alternation is a pi. Or also we can consider this one is one half cycle or one alternation, one alternation, or we can say half cycle. So both are same only. I mean, the what I want to say means the cycle of the any alternating quantity simply defined. It is the set of two different alternations. So that's simply called cycle. And the next one we can go to this other one is a frequency. So frequency we have to define. So we have to define from the time period. So it is denoted by always capital EF. So need to take some mathematics here. I mean some analysis. So based on that one, so we can take it as a, so the time period we know that t equal to, that is a second upon cycles. So I mean how much time in second to finish one cycle, that's called time period. We have already discussed it. So based on this one, we need to go with the reciprocal of time period. Then we will get the, so that is a cycles per second we got. So it is a cycle per second. The 1 by time period, I mean to say the reciprocal of time period, we can simply consider as a frequency. So frequency, that is a f equal to means cycles upon seconds. So the frequency can be defined. It is the number of cycles per second, or the number of oscillations per second, or the number of cycles per second is simply called frequency. Or also other words we can define the frequency, that is it is a reciprocal of time period, also say frequency of the any alternating quantity. So this is the basic things about the AC circuit, that is a time period, cycle, then alternation, and also the frequency, and other things also we need to discuss. That is that is angular velocity. After that is angular velocity. It is a angular velocity. So angular velocity nothing but, so it's always denoted by omega. So that means it is the rate at which the object rotates. I mean to say the angular velocity nothing but it is the rate at which an object rotates is simply called angular velocity. So that W equal to, we can consider as a distance upon time in seconds. Distance upon time in second. So this here, this one we need to consider about either the degrees, so degrees or radians. So this is the notation of the angular velocity. So the angular velocity we can simply consider that is omega equal to distance upon time in seconds. So it is denoted by omega equal to, so either we need to consider the distance as in terms of radians or degrees. So we can take the theta as a distance, then upon time in seconds. So this one we have to consider about the as a radians. So the theta we need to consider always in terms of the radians only. So this one in terms of seconds. So therefore omega equal to theta upon t, that is radians per second. So it is nothing but the angular velocity nothing but, so it is the rate at which an object rotates, that's called simply angular velocity, that is a radian per second. So the angular velocity always we need to measure in terms of the radian per second. So from this one we need to write the theta value, that is the theta equal to in terms of radian, that is omega t. So either theta or we can consider as the radians should be the omega t. So radian per second or the theta, or we can take it as that is omega t. So we have considered the theta as what? Theta as a radians, right? So theta as a radian means, so if you are able to take this one omega t, so the unit of omega is a radians per second. So into then time units are the second. So second gets cancelled. Finally we will get the theta value. So theta value in terms of the radians only. Omega t also we can consider as in terms of radians, and theta also we can consider as in terms of the radians. So that's why this is the angular velocity of the any signal. So till now we have discussed about the what does it mean by alternating quantity, and what do you mean by AC current, and what do you mean by time period, and what do you mean by instantaneous values, and what do you mean by magnitude value and peak value, and also the So then the angular velocity, frequency of the system, cycle of the any alternating quantity. So these many things we have discussed till now. So this is the end of the session. Thank you, Vandal. Thanks for watching.